guys. I just realized I didn't scooch up over some of these things, so you're not going to be able to see them too well. Well, we'll see how this goes. Good morning and happy Tuesday. And you may have already seen me this morning doing math. I don't know what order you guys do stuff in, but I guess that's kind of one of the nice things about being doing this at home is you kind of can do them in whatever order you prefer. So today's our Tuesday school day. So this is what we would be doing if you were at school today. I would have already printed out and handed out the notes that hopefully you've already printed out. Sorry, all of a sudden I'm itchy. I'm sitting in a different room, so it's a little bit more of an interesting background in my house. So hopefully you already have your notes. And so we're going to kind of talk through the slides as we go into chapter 4 in this astronomy unit. And this is about the seasons and basically how the Earth's tilt affects our seasons. So you've probably already learned a little bit about the Earth's tilt in the past and about the seasons. This is just kind of like everything we're going to do here. The inquiry lab, I don't think a couple of these activities didn't really work well, so I cut a couple of them out, but you'll see. So hopefully you've got your notes. So grab your notes and mind's on, meaning like let's put your thinking cap on, put your mind on, and let's ask a couple of questions. So a couple of questions are, why is it cold in the winter and hot in the summer? And you're going to say, well, because just it's summer and we get hotter weather, and it's winter and we get colder weather. But why? So I don't know. I can't hear you. What? I don't know. Hopefully some of you are giving me some kind of input as to why you think it's cold in the winter and hot in the summer. And then what about places near the equator? Why is their temperature pretty much constant throughout the year? So why do we here in North Texas, which is the southern part of the United States, but kind of the middle of North America, not exactly in the middle, but closer to the middle of North America, but we're definitely north of the equator. Why do we have cold weather in the winter? Or why does even Australia, who has winter when we're having summer, why is their winter cold? Why is it cold? And why do the countries close to the equator have pretty much the same temperature, not as big of a variety in temperature? So that's what we're going to hopefully talk about today. You may have already said some things out loud, and we'll see how well you know this stuff as we continue to talk about it. So here's just Pontianak, I don't know how to say it right, in Indonesia. So here's this city in Indonesia, and here's the equator. So this city is in Indonesia, and it's right sitting there at the equator. So here's another zoom in of it. If we had the equator drawn, which it's not drawn on this map, you can see that it's right there pretty close to the equator. Okay, so here are some of the average temperatures there in this Pontianak, I don't know. These are in Celsius. So these are, for the most of the time, this is January through December, they hover right around 32 to 33 degrees as their highs, because the orange is the average high temperature. And then their lows are right around 23 other than May. So I mean, look, it is almost the same temperature there in the daytime, their highs, and almost the same exact temperature, their lows all year long, which is crazy. That'd be like if it was here in Texas, it was pretty much 80 degrees every day as the high, and then the low every night was like maybe 60 degrees pretty much every day, 12 months out of the year. That'd be crazy. Kind of nice though. Maybe 75. No, 80 is good. You want to be able to swim in your pool. Okay, so why is it? Why do we have such a difference in temperature, and why does somewhere a country along the equator not? Well, the Earth's rotation definitely affects it. And then we're also going to talk about the tilt. So just to kind of review the word rotation, and this is something you'll jot down in your notes. Remember, if it's in bold, it's going in your notes. It's the spinning of an object around its axis. So if I don't even have a ball. Usually I do. There's my ball. Oh, wait, okay. So if I'm rotating it, if I was really good and I could spin a basketball on my finger, can any of you guys do that? Spin? Okay. So pretend I'm spinning this on my finger. So that's rotation, okay? It's spinning on its axis. This would be an axis, which is just like an invisible line going straight from the top through the bottom is an axis. So it's going to be spinning Again, imagine somebody spinning a basketball on their finger. Okay. Obviously, we know for Earth, for us, one day is about 24 hours to spin around, right? On its axis. Okay. So you've added rotation. So Earth's rotation is, and you learned this in first grade if you were in first grade with me. I know you guys know this. Okay, so while it's rotating the Earth, if the sun is over here, well, you can't see. So normally we act this stuff out in class. So feel free to act this out with a sibling. One of you can hold a flashlight, and I should have grabbed a flashlight. One of you can hold a flashlight, and the other one can hold a ball, and the part that the flashlight represents the sun, and the part that it's shining on is getting daytime. And then obviously as the Earth rotates, we get nighttime. So the sun does not rise and set. We say the sun rises and we say the sun sets, but really the sun never moves. We're rotating. So it's the Earth's rotation that causes half the planet to face the sun during the day and get daytime, and half of it to face night. So there's always half of the Earth that's dark and always half of the Earth that's day. Review. Okay, so how does our tilt play a role in the seasons? We know its rotation affects night and day. So what the heck is up with the tilt? Okay, so remember I said an axis is like an imaginary line that goes from north to south, right? So it goes straight through it. Well, this would be a 90-degree angle, right? You know about triangles, when we talk about angles in geometry. A right angle is a straight, almost like an L, right? Okay, so this would be at 0 degrees perpendicular, just straight perpendicular to another line. But Earth's axis is not straight up and down. It's actually tilted 23.5 degrees. And that is the main reason why we have the variation in seasons. And so we're going to talk a little bit about that today. So here's that perpendicular line. Okay, and this, if Earth wasn't tilted, this would be that axis, but it's not. It's tilted. You ever notice when you're looking at a globe, which, we used to have a globe. We don't have one anymore. The globe is always on a tilt, so because that's what the Earth is. Okay, so how does that affect the seasons? Okay, so a revolution, so we had rotation, and that's just the object turning once, right? Daytime, 24 hours. A revolution is different. The revolution is the time, the movement of an object traveling around another object. Okay, so it takes the Earth 1 year to travel in a circle around the sun. So this is one revolution down here in the bottom around the sun. And so because we are traveling around the sun, one of the cool effects on the Earth is that we get to see different constellations at different times of the year. So if we're over here, we're going to see some constellations out here in our solar system that are not as visible when the Earth is way over here in winter. So in summertime, we're going to see some constellations maybe over here that we can't see as well when we're over here in winter. And in winter, we might see some constellations that are maybe way out over here that we can't see when we're over here. So it's kind of cool. Depending on where we are in our revolution or the orbit, which is that path around the sun, we're going to see different constellations. So that's pretty cool. But also another effect on our revolution is it causes the tilt to create seasons. So that's the other thing you want to write down. So the revolution causes the tilt to create seasons. Okay, so jot that down, and then we're going to go into why. Why does its revolution around the Earth cause this tilt to make seasons? So we have a tilt, we know that, and because it's going around the sun, that is going to give us the seasons, and that's what we're going to talk about today. So I know it says use the diagram below to explain how the tilt and revolution of the Earth around the sun causes the seasons. And I put a picture of this in your notes. So my goal is that after we talk about it, you should be able to maybe explain it to a parent or to a sibling. So we're going to start over here. And there's a really good video that I didn't link. I'm not going to play now, but I want you to watch after, and it animates this really, really well. So, oh, crud. Oh, I went backwards. Okay. So if this is the way we're tilted, like say, remember we're in North America, so we're kind of right around here, right? If I'm standing right here on the Earth and the sun's rays are going straight towards the Earth, okay, this part, because it's tilted, it is going to get more sunlight, which means more warmth, more energy, because it's tilting towards that warmth. Whereas the southern hemisphere down here below the equator is tilting away. It's kind of like if you were, like standing close to a fire, like I can't think, an outdoor fire, like campfire. Sorry, I can't think of the word. And and you were holding something, straight up. But if you tilted your arm a little bit like this over the fire, the part of your arm that is over the fire, this part, sorry, let me get back in the picture. If the fire is right here, right, this is going to be a little hotter than the part that's tilting away. So if you imagine straight up and down the earth, if the sun was hitting the earth at a 90-degree angle, we would all be getting the same amount of heat. But because it's tilted, this part here is tilted closer to the sun. It's going to get more sun than the part that's farther. It's going to get more energy and heat from the sun than the part that's tilted away. So it's kind of like I said, the video is good because it shows the animation better. So that's why when we are on this side of the sun, whatever side that is, and we are tilted, when North America is tilted towards the sun, we're going to have summer. Okay, and then anybody south of the equator, like Australia and parts of Africa and everything, they're going to be having winter. Okay, so then as you go over here to the side of the sun, because you're on a tilt, and now the sun is hitting at you. Sorry, it's really hard to show this. This is so much easier in person, but that's okay. Y'all hang with me. So because I'm going to use my hand again, because we're at a tilt and now the sun is shining. You can't see me. Anyway, so now the sun is shining this way, okay, versus earlier the sun was shining this direction and it was getting the tilted part more. Now the sun is coming at you in this direction or from this direction, and it's pretty much going to get everything a little bit more evenly, okay, because we're tilted, it's going to be a little bit more even. So now the fall and spring, fall and spring weather is pretty similar, right? In the spring and the summer, in the fall, we can say our weather is very similar. So whichever the northern hemisphere will be experiencing fall, and then the southern spring. And then as you get over here, and we get like half. So this would be like, amazingly, these are all quarters, aren't they? There's 12 months in a year. So this from summer to fall is 3 months, right? And then from fall to winter is 3 months. So we'll say that this is June because that's the summer solstice, which starts usually it's like June 20th, 21st, and then till about the autumnal equinox, which is when fall starts, and then it's in September. And then 3 months later in December is when we have the winter solstice, and that's when winter starts. And now we have northern hemisphere pointing away from the sun. So now we're tilting away. The sun is over here shining on us, and we're not getting it. The southern hemisphere is getting it more. And then 3 months later, we have spring again, which is in March. And that is I'm getting my equinoxes. I'm drawing a blank. Somebody help me. Okay, thank you. And then another 3 months later, we get to summer again with the summer solstice, okay? So this is every 3 months, you're changing seasons, and it's because of the position of the Earth in its revolution around the sun and based on how it's tilted and what part of the north or southern hemisphere is facing the sun or facing away from the sun. It's basically a good way to say it. So why is it cold in the winter and hot in the summer? Okay, because in the winter, we are in the northern hemisphere facing away from the sun. We're tilted. The tilt is tilted away from the sun. In the summer, our tilt is tilting towards the sun. Places near the equator, their temperature is pretty much the same because they're getting it. They're getting pretty much the equal amount of sun all year. Okay, because they're never tilted away. They're pretty much getting the same amount of sun all year. Okay, so this is the video that you'll watch at the end, because when I try to play videos within a video, I don't get good sound. So the question, and I already answered, is the seasons are caused by the Earth's tilt. The tilt of the Earth causes different parts to receive different amounts of direct sunlight versus if you're tilted towards it or tilted away. The people on the equator receive approximately the same amount of direct sunlight all year. Therefore, their temperatures are mostly constant throughout the year. And so that example that we were looking about in Indonesia, that's why theirs are pretty constant because they're pretty much getting the same amount of sun. So this is the little baby going, Eureka, because he figured it out. All right. So this activity, I was really disappointed. I couldn't get it to work. I was going to share it with you guys. I shared a different one with you guys, but this one I couldn't get to work at all. But I did look up our latitude in Fort Worth is 32.768799 degrees. So you're going to add this on the blank in your notes. It tells you to open the simulation. I couldn't get it to work. So we're just going to pretend that this is our person, and he is, this isn't North America, but we're going to pretend like this is North America, and this dude is standing at about our latitude, okay? And then the sun's rays are shining directly down on him. And this is really cool too because it shows the view from Earth. So from Earth, it's not a 90-degree angle, but it's pretty close. It's a pretty close angle straight down. We're getting direct sunlight here. So if you place your person there and then you observe how the light strikes the person during January, March, July, and September, each of the different equinoxes and seasons. Why am I forgetting equinox? Solstices. Thank you. A lot of information in my brain. I can't remember it. So this is another picture of him. So like there's the dude again. Oh, this one is showing North America. So that one's better. Okay. So right here, this is North America in January. Okay. So in January, the North America is not, and the sun is over here. So this looks like it's straight up and down. See how the axis is straight up and down? That's because the sun is over here. So we're still tilted. But notice how North America is facing away. So this part of the southern hemisphere is going to be getting a lot more direct sunlight. We're still going to get sunlight. It's just not as direct. So see how our person isn't getting quite as much sun. And North America isn't either. And the sun is the beams are coming at much more of an angle. So we're not getting nearly as direct sunlight in January. So it's warm. I mean, we still have daytime. It still gets warmer during the day, but see the angle that the rays or the warmth or the energy from the sun is coming at an angle versus North America in July, where the sunlight is coming almost directly down on us, and we're going to get a lot more. I know that's not showing North America either, but it's the best I could do. Again, the video is much better at explaining this. So let's add this too. The more direct sunlight an area gets, the warmer it is. That's the key. The more direct sunlight an area gets, the warmer it is. So in what season is North America tilted towards the sun? That would be summer. Okay. In what season is North America tilted away from the sun? That would be winter. And in what season does the tilt not really affect the temperature? What would that be? Winter and fall. I'm sorry, spring and fall. Or you could say spring and autumn if you want to be fancy. Okay, so make sure you answer these. I know that they're not in bold, but on your notes, North America is tilted towards the sun in summer. It's tilted away from the sun in winter, and we're not affected that much in the fall and in the spring. We have a similar weather. Okay, so again, in North America, it is summer in June, in July and August, and then it's winter in South America, because in June, I'm making up new words, June, July, and August, North America is tilted toward the sun, getting more direct sunlight, and South America is tilted away from the sun, getting less direct sunlight. So that's a lot to write there. You may have to pause for just a second so you can get that jotted down. I'm going to keep going, but you can pause if you need to. Oops. Okay, so this is actually really cool. This is what I want you guys to do. It's listed as the next thing for science. This one I did get to work, and I'm going to click on it and show it to you. You're going to open the animation. This is clicking on the image, but I actually linked it in the next assignment. So you'll click on it in the next assignment. You're going to make the inclination angle of the Earth a 23-degree angle. We can't do 0.5 in this, just 23. And then click trace the sun's path. And then we're going to record our observations of average daily temperature and the sun's path, not on the following slide, but in your notes. You'll notice this inquire activity is actually page 4 of your notes, the last page of the notes. And then this is also in the notes. It says to sketch it. So basically what I'm looking for is if it was summer, I might sketch the sun here and then sketch the Earth on a tilt with North America facing. So show my axis on a tilt, like here's the Earth, here's my tilt. Maybe I'll label this as North America, this is South America. And then you can even draw rays from the sun coming and hitting North America more directly. And then on winter, you might jot, here's the sun again, here's the Earth on its tilt, draw its axis. No, actually, sorry, we're on the other side now. For winter, you want to put the sun over here, and you want to put the Earth over here, still on its tilt. Here's the Earth, here's its axis, and North America is over here facing away, and South America is over here tilted closer, and then you can show this. It'll make more sense after you watch the video that is after this that shows the animation better. What do you notice? What is the sun's path effect? These are just things for you to respond. This is one of the things you probably will notice. In the winter, the sun doesn't get as high in the sky, and therefore we see it for less time, and we have shorter days, and we receive less direct sunlight. So this is important. We know in the winter that it gets dark by 5 or 5:30, and we're like, why? Why does that happen? And so as you play with the little animation, you'll kind of see that we basically just, the sun doesn't get as high in the sky, and so we just don't have as much daylight. We're getting less direct sunlight. And in the summer, the sun takes a much longer path across the sky, even though it's not really moving, we are. So we see it for more time, we have longer days, we receive more direct sunlight, and it's hotter. This is just the word more that you can't see behind me right here. So you can actually go ahead and jot these down on the last page, even though you haven't done the interactive activity yet. Okay, the Seasons Lab, that I forgot to delete this slide. And then that was a really, really long video, so I decided not to show it. It's all right. It's actually not that great. So what I do want to show you, wait. Actually, I'm going to go out of this, and I'm going to show you, this is where you found your notes and you watched the video, and now you're going to go to the Seasons Interactive Activity. You're going to click here, and it may prompt you to download Flash or enable Flash Player. Sometimes mine started to pop up, and earlier I enabled it. Nope. Let's see if I can get it to ask for it. If I get it to ask for it, that's even better. Come on. Oh, here it is. Okay. So sometimes like a little puzzle piece will show and it'll say enable Flash Player, and you just have to enable it. Sometimes it's blocked in your browser in Chrome, which is what you're using, Google Chrome, and you may have to go in and unblock it. And if you might just need to get a parent to help you with that, the easiest thing for me to do is I just Google how to unblock Flash Player in Google Chrome, and that walks you through the steps. It takes like 10 seconds. Okay, so you should be able to get this to work. Before you play around with it, there's a few tabs. You can read up a little bit about the seasons. You can read up a little bit about how to use the interactive part. And so here's the interactive part. Right now it's showing you, there's a couple things it's showing you, and there's this little menu here that you can scroll up and down, and it's going to explain every part of the screen. So you can read about that. Okay, I'm going to go ahead and close it because I'm just going to kind of explain it to you. So right now we are in spring because we started over here. I think we were in summer. No, we were over here in winter. So it's spring. And so it shows you can slow it down, you can speed it up, you can do trace the sun. One of the things we need to do is put it at 23 degrees because right now it's not at 23 degrees. It was as if the sun was just, oops. Okay, here we go. And you can speed it up if you want. So right now it's tracing. The reason you want to hit trace the sun's path is because as you watch the sun do one complete revolution around the sun, you're going to notice that the sun is higher in the sky in the summer. And then when you get to winter, if we speed it up, let's speed it up really quick for just a second. Get to winter. Okay. You're going to see how much lower in the sky it is. You see how much lower it is? So in the summer, we were getting that really high arch. So that's why we get those longer days. But in the winter, we get, look how low the sun is in the sky. That's why we have such short, it's dark by 5:30. So kind of just play around with this. You can speed it up. You can slow it down. You can look at Earth. You can look at Venus. You can look at Uranus. And I really just kind of want, and also notice the temperature. The temperatures right now, we are in winter, right? And so notice also that shows you the angle that the sunlight is hitting the earth, where it's located right now in its revolution. So we're not getting direct sunlight versus if I speed it up and get to summer, go back to slow. So you notice this angle now is getting closer to a 90-degree angle as we are in spring. And then if I go a little faster, and then get to summer, now we're getting even more direct sunlight. So it's just kind of a fun thing for you to play around and see how it all works. So kind of play around with this, answer what you can in your notes. It's just more of an exploratory exercise for you guys to have something interactive, because normally we would get up in class and have flashlights and balls and act all this stuff out. But honestly, this is actually a really cool interactive thing for you to understand it. So watch the other video. It's only a couple minutes. And then, play around with this. And that's all you've got to do for today. So hope you guys learned something about the seasons and can answer some questions tomorrow. All right. Have a great rest of your day. I was going to say evening, but it's daytime for you. Bye, guys.